Hi, boys and girls. So today we're going to focus in on multi-step story problems. These are the type of story problems where you don't just do one step. There are multiple steps. There could be two steps, maybe even three steps that you need to take in order to solve the problem. This is much closer to how problems are in the real world. When we think about doing math in the real world, most problems aren't just one step. They're mostly a couple different steps. In order to do this, you'll need to know some terms for an addition problem. The answer to an addition problem is called the sum. The answer to a subtraction problem is called the difference. The answer to a multiplication problem is the product, and the answer to a division problem is the quotient. And when we write our equations today, we will be using what are called parentheses. It's kind of a hard word to say, parentheses. So we're going to start in by doing a multi-step story problem. And as I read this, I'm going to stop and think. After each sentence, I might stop and think. I'll probably read it first all the way through and then go back and visualize. Betty baked 5 sheets of cookies for the bake sale. Each sheet contained 12 cookies. She donated 18 cookies to her local brownie troupe. How many cookies did Betty have left to sell at the bake sale? Okay, so let's picture this. Betty baked 5 sheets of cookies for the bake sale. Okay, I can picture 5 trays. Each sheet contained 12 cookies. So you might make like a rectangle like this with 12. And since there are 5, each rectangle representing a sheet, since there are 5 of them, 1, 2, 3, 4, 5. It's not working. There we go. So these are the 5 cookie sheets with 12 cookies on each sheet. You don't have to write the number 12. You could actually draw 12 circles if you want. I just think writing the numbers sometimes takes less time. It's a little more efficient. Now, we're not done. Just because we can figure out how many cookies she made, we still have another step. She donated 18 cookies to her local brownie troupe. So we have to remember to come back and do this after we solve how many cookies she made first. So this is 12 times 5, and if you remember how we would set this up from the other day, the small number goes here, the 12 gets broken up into a 10 and a 2, right? And then 10 times 5 is 50, and 5 times 2 is 10. So she starts out by making 60 cookies. And then the second step is 18 cookies were donated. So when you're donating something, you're giving it away. So we have to find the difference of 60 minus 18. Now, if you remember, you could stack this, obviously. But when there's a 0 in the ones place, that definitely means you are going to have to trade. So what I want to do is actually, I'm going to do constant difference, where I'm going to take 2. I'm going to add 2 to 18, and I'm also going to add 2 to 60. The reason why I added 2 to 18 is because I wanted to make it a friendly number. So if I rewrite my equation, 18 becomes 20. And of course, since I added 2 to this side, if I want it to be the same difference, I also had to add that 2 to this side. So 62 minus 20, that's really easy. I can do that in my head. It ends up being 42. And the answer is 42 cookies. Now, that is how we solve the problem. What about writing the problem in equation form with parentheses? So I'm going to delete this stuff here, and I'm going to make room. So the first step, hey, why is it, what the, all right, here we go. Delete. First step, we are going to we had to find out how many cookies we were, and what I just deleted were those sheets of 12. So we did 5 cookie sheets of 12. We knew that was multiplication because it was adding the 12 plus the 12 plus the 12 5 times. And I'm going to put that first step in parentheses. And then the second step, she donated the 18. So I'm going to subtract 18, and that ends up equaling 42 cookies. So that is how we solve a multi-step problem. Let's try another one. That one that we just did, it was multiplication and then we subtracted. Let's see what happens on this next one. Betty sold 42 cookies. Okay, so it's still Betty. Hey, that was the answer, 42. She sold all 42. Each cookie sold for $2. Okay, I'm picturing that in my brain. The cost of the ingredients to make the cookies was $25. How much profit did Betty make? Okay, so here's a economics word, profit. So she sold 42 for $2 each. So that means each cookie is $2. So if I drew 42 of these cookies and put a 2 on it, that's going to take a long time though. I don't feel like doing all that. I already know that that's multiplication though, because it's 42 times 2. And whenever you times 2, I always think about doubling it. 42 cookies, and they're all $2 each. So if you double 42, I'm actually not even thinking about multiplying. I'm actually thinking 42 plus 42. In fact, I don't even really need to write this down, but I will. I know 2 plus 2 is 4, and we don't have to regroup. It's just 84. So she made $84 on the cookies, but the ingredients, before she even sold them, she had to go spend $25 to buy all the ingredients first. So sometimes it takes money to make money, right? So she sold 84, but we're going to subtract from the 84 that $25 that she invested in the cookies. So 84 minus 25. Well, let's try a constant difference again. I want to make this small number into a friendly number. If I add 5 here, that means I'm going to have to add 5 here also. If I add 5 here, that makes it a 30. And 84 plus 5 is 89. And that becomes an easier problem. 89 minus 30. Well, I know an 8 is a 5 and a 3. So 80 minus 30 is 50. And then the nothing happens in the ones place, 59. So the answer is she made $59 from her cookie sales. That means she made $84, but it cost her $25 to make the cookies. So she had made a profit of $59. Well, now we're going to make this into an equation. So the first step was we had to find out how much money she made. How much money did she collect, I should say, when she made the cookies? So it was 42 cookies doubled, right? Times $2. And that was our first step, and we put that in parentheses. Then we have to take away the $25 in order to find out how much money she actually put in her pocket at the end of the day. So the answer with the units is 59. So sometimes the units is just like simply a dollar sign. It doesn't need to be a noun like cookies. It can just be a symbol like a dollar sign. She made $59. And this is the equation. 42 times 2, in parentheses, step 1, minus the $25. Okay. So we'll do one more. This one at the pet store, clownfish costs $8 each, and the tangfish costs $6 each. Gil bought 7 clownfish and 2 tangfish. So now we're knowing how much. Now we are learning that the clownfish are 8 and the tangfish are 7. And then we find out that Gil bought 7 clown and 2 blue tang. Maybe I'll color code this since I have the ability. 2 tang and the blue, everything blue is for the tangfish. There we go. So we have kind of 2 separate problems here. We have to find out how much did Gil spend on the clownfish. And then we also have to find out how much Gil spent on the blue tangfish. And then find the sum of both of those, because we have to ultimately figure out what did Gil spend in all. So in order to do that, if each fish costs $8, each clownfish is $8 and there's 7 of them, well, that's a repeated addition. 8 for 1 clownfish, 8 for 2, 8 for 3. And we're going to go all the way up to 7. So that's actually 7 times 8. And that's a math fact. And I remember 5, 6, 7, 8. That's 56. So Gil spent $56 on the clownfish. Then the tangfish are $6 each. And he bought 2 of those. So this number goes with this number. So 2 times 6 is 12. Keep in mind, I could have done 6 times 2 or 2 times 6. It doesn't matter the order. So then we have to find the sum, which I'll do over here. 56 plus 12. Forgive my slopper dopper Burger King Whopper writing here. 8, 6. I added down the ones and then the tens. It's $68. No regrouping again. We got lucky. But yeah, it's hard to write with this mouse pad. Okay, so the answer was how much did Gil spend? Well, our unit was 68, but Gil spent $68. So let's rewrite this in the form where we use parentheses. So our equation is just one equation. We don't have separate equations. So the first step was 8 times 7, right? So instead of writing the answer to this, I'm going to put it in parentheses, 8 times 7. And then we added that answer, that product, to when we did the 6 times the 2. Notice the first time I wrote this, I did 7 times 8. Now I wrote it at 8 times 7. It does not matter. And then our answer ends up being our buddy Gil spent $68. Okay, so hopefully this will give you a little insight on how these multi-step equations with parentheses work. When you're writing them, it's a little bit different than solving them, I think. I think it's a little bit more challenging. But I always keep in mind, my first step I'm going to put in parentheses, and then the second step, I do that last step or the second step, I apply it to what was already in parentheses. In this one, we had 2 separate parentheses, and then we had to add them together. So it can be a little different, but you definitely are capable of doing it. You just need to think about what's happening in your brain. Just like being a really good reader, your reading skills have to apply to your math skills.